Some of these machines hauled millions of tons across America before GPS, electronic logs, or computers even existed, and truckers today still argue they'd take them over a brand new rig any day of the week. Modern semi-trucks have touchscreens, lane assist, and automated transmissions, but there are 10 legendary 18-wheelers from decades past that engineers, drivers, and historians agree solved problems that today's trucks haven't, and maybe never will. Number 1. 1969 Kenworth W925. Let's start with a truck that practically defined long-haul culture in America. The 1969 Kenworth W925. Kenworth introduced this conventional cab model as a flagship heavy hauler, and it earned a reputation for being nearly indestructible. The W925 was powered by Cummins NTC335 and NTC350 diesel engines, producing between 335 and 350 horsepower, numbers that sound modest today, but were considered elite in 1969. What made this truck almost impossible to replicate isn't just its power, it's the cab design. The W925 featured an all-aluminum cab construction, which dramatically reduced weight without sacrificing structural integrity. Drivers praised its exceptional visibility, with a wide panoramic windshield that gave an almost unobstructed view of the road ahead. Modern trucks, despite their technological sophistication, often feature high hood lines, aerodynamic nose designs, and camera systems that still can't match the raw sightline a driver had sitting in a W925. The engine compartment was completely accessible, no plastic covers, no electronic locks, no dealer-only diagnostic ports. A driver could rebuild the engine roadside with basic hand tools. That level of field serviceability has never been matched. The W925 also had a significantly longer wheelbase option that gave it stability advantages when hauling oversized loads on mountain grades. Many heavy haul operators in the 1970s specifically chose the W925 for routes through the Rockies and Sierra Nevada because of how predictably it handled under extreme load and grade. Number 2. 1970 Peterbilt 359. If there is one semi-truck that has achieved almost mythological status in American trucking culture, it is the Peterbilt 359. Introduced in the late 1950s and refined through the 1960s and 1970s, the 359 became the defining image of what a big rig should look like and how it should perform. The 1970 version represented the pinnacle of its evolution. The 359 was built on a heavy-duty steel frame with double-frame rails, making it one of the strongest chassis ever produced for an over-the-road truck. It was commonly powered by the Cummins Big Cam or the Detroit Diesel Series 60's predecessor, the 8V71, though the Caterpillar 3406 was also a popular choice. Drivers consistently reported that the 359 had a ride quality, particularly on uneven highway surfaces and gravel roads, that modern aerodynamic trucks simply cannot match. The reason is in the suspension geometry. The 359 used a long, low-slung leaf spring suspension with significant travel, which absorbed road imperfections in a way that modern air ride suspensions, engineered primarily for fuel efficiency and load protection, do not replicate for driver comfort over rough terrain. The 359's cab was also famous for its near-flat floor, giving drivers exceptional interior space and the ability to move freely between the bunk and the driver's seat. It had a cab height that placed the driver at a natural sightline for negotiating tight loading docks and urban intersections. The 359 remained in production until 1987, and examples are still commercially operated today, a testament to the longevity of its engineering. Number 3. 1973 Mack R-Series. Mack Trucks has built rugged equipment since 1900, but the R-Series, introduced in 1966 and dominant through the 1970s and 1980s, represents the brand at its absolute peak of legendary status. The 1973 R-Series, particularly the R685ST and R700L configurations, was powered by Mack's own Maxidine engine, the ENDT675 or ENDT865, producing up to 285 horsepower. What made the Maxidine remarkable was its extraordinarily wide torque curve. It produced peak torque from around 900 RPM all the way up past 1,600 RPM, which meant drivers needed far fewer gear changes on grades and in traffic. The Mack R-Series was paired with the Mack Maxitorque transmission, an 8 or 10-speed gearbox specifically engineered to work with the Maxidine's torque band, allowing a skilled driver to operate with as few gear shifts as some modern automatic transmissions require. The cab of the R-Series was constructed almost entirely of fiberglass, which was a revolutionary material choice in 1966 and gave the truck corrosion resistance that steel cab competitors couldn't match. Mack R-Series trucks operated in salt belt states for 30 or 40 years without the structural rust deterioration that plagued contemporaries. The drivetrain was also Mack proprietary. Axles, differentials, the engine, the transmission, all built in-house, which meant parts compatibility was extraordinary and quality control was consistent. That level of vertical integration in manufacturing has not existed in the trucking industry for decades. Number 4. 1975 White Freightliner WFT 8164. The White Freightliner partnership produced some of the most aerodynamically advanced trucks of the pre-computer era, and the WFT 8164 from the mid-1970s was their crown jewel. What set this truck apart was that White Freightliner was thinking about aerodynamics years before it became an industry-wide obsession. Their cab-over-engine designs were engineered with wind tunnel testing in an era when most manufacturers were still focused exclusively on mechanical durability. The WFT 8164 cab-over configuration placed the driver directly above the front axle, giving the truck exceptional maneuverability in tight dock situations and allowing for a shorter overall vehicle length for a given trailer combination, a critical advantage under bridge law and length restriction regulations. The cab tilted forward for complete engine access, exposing a Detroit diesel or Cummins power plant that mechanics could service from all four sides simultaneously. The cab interior was spacious despite the compact exterior footprint, and White Freightliner pioneered some interior ergonomic features, dashboard layout, instrument clustering, bunk positioning that influenced cab design for the next 2 decades. Many freight companies in the 1970s preferred the WFT 8164 specifically for urban distribution and LTL operations where maneuverability, fuel consumption, and driver comfort during multi-stop days mattered more than pure highway speed. Modern cab-over trucks have largely disappeared from North American roads due to regulatory changes, but operators who use the WFT 8164 extensively will argue that no current North American semi matches its urban operating efficiency. Number 5. 1978 International Harvester Transtar 4300. International Harvester's Transtar series represents a period when the company was investing heavily in driver comfort and long-haul capability, and the 4300 from 1978 is the best example of that philosophy. The Transtar 4300 was available with a raised roof sleeper cab that was, at the time, one of the most spacious sleeping compartments available in a production semi-truck. It measured approximately 60 inches of interior standing height in the bunk area, a number that many modern-day sleepers only barely surpass. The 4300 was powered by options including the Cummins NTC 400 Big Cam, producing 400 horsepower, and the Caterpillar 3406, both of which were workhorses of the era. The truck also featured an advanced climate control system for its time, a 2-circuit HVAC arrangement that allowed the cab and bunk to be conditioned independently, which was ahead of nearly every competitor. The Transtar 4300's frame was built for vocational heavy hauling, with reinforced crossmembers and a high-capacity fifth-wheel mounting that allowed it to carry 80,000-pound gross loads without frame flex that drivers could feel. International Harvester's reliability in this generation was extraordinary. Many fleets reported the Transtar 4300 operating past 700,000 miles on original engine components with only routine maintenance, a longevity metric that modern EPA-compliant engines with their more complex emission control systems have struggled to routinely match. Number 6. 1980 Kenworth W900A. The Kenworth W900 is arguably the longest continuously produced semi-truck model in history, having remained in production from 1961 to the present. But the 1980 W900A represents a specific golden era of the model, before emissions regulations began requiring significant engine and exhaust modifications, and truckers who drove both the pre-emissions W900A and modern W900 variants are near universal in their preference for the 1980 configuration. The W900A was available with Kenworth's signature long hood design stretching over 100 inches, housing Cummins, Caterpillar, or Detroit diesel engines in displacements ranging from 14 to over 15 liters. The long hood gave the engine compartment extraordinary space, making maintenance and repair work dramatically faster than on modern configurations where components are densely packaged around emission control equipment. The 1980 W900A had a high torque output at low RPM that provided exceptional pulling power on grades, particularly important for operators in Wyoming, Colorado, and the Pacific Northwest, where mountain grades are sustained and steep. Driver feedback from the era consistently notes that the W900A's steering feel and road feedback were exceptional. The recirculating ball steering gear gave drivers tactile information about road surface and load shift that modern power-assisted and electronically managed steering systems filter out. Many experienced drivers argue that this feedback made them safer operators, not less safe, because they could sense problems developing before instruments or warning lights registered them. Number 7. 1982 Freightliner FLC 120. Freightliner's FLC 120 from the early 1980s represents the company's ambition to build the ultimate long-haul highway truck during a period when fuel costs had become the primary operating concern following the oil crises of the 1970s. The FLC 120 used aluminum extensively throughout its construction. Aluminum cab, aluminum hood, aluminum fuel tanks, and aluminum wheels were all available as a package that reduced the truck's tare weight to levels that gave operators significantly more payload capacity under federal weight limits. A fully equipped FLC 120 could weigh as little as 14,500 pounds, an accomplishment that modern trucks packed with electronic systems, emission control equipment, and safety technology struggle to approach. The FLC 120 was aerodynamically styled with a raked windshield and integrated fairings that, when combined with roof fairings and side extenders, produced drag coefficients that were genuinely competitive with early 2000 designs. Freightliner was that far ahead. The cab was also built with exceptional sound dampening for the era, double-pane glass, foam-filled door cavities, and a cab-to-frame isolation mounting system that reduced driver fatigue on multi-day runs. The FLC 120 was commonly paired with Detroit Diesel's Series 60 predecessor and Cummins Big Cam 4, giving operators fuel efficiency numbers in the 6 to 7 miles per gallon range at highway speed. Numbers that represented a significant advancement over the industry average at the time. Number 8. 1985 Peterbilt 362. Peterbilt's cab-over-engine 362 was the company's answer to operators demanding maximum payload in minimum length, and the 1985 version represents the model at its most refined. The 362 was a tilt cab design that gave complete access to the engine, a Detroit Diesel 8VU 92TA, a Cummins NTC 400 Big Cam, or a Caterpillar 3406B were the primary power choices. The cab tilt mechanism on the 362 was manually operated with hydraulic assist and could be performed by a single driver without special tools in under 10 minutes, exposing the entire engine, both sides of the frame, and all major service points simultaneously. No modern tilt cab truck, and very few exist in North America anymore, offers this level of access. The 362's interior featured Peterbilt's legendary build quality, riveted aluminum construction, precision-fitted panel gaps, and a level of material quality in switchgear and trim that gave the cab a sense of permanence that plastic-dominant modern interiors don't replicate. The bunk in the 362's sleeper configuration was positioned low and wide, giving a stability to sleep that high-mounted modern sleepers, which rock more noticeably during wind or traffic turbulence, can't always provide. Peterbilt 362 operators in the western United States frequently chose the truck for oversized load escort and heavy haul operations because its short overall length combined with its heavy-duty frame rating allowed configurations that no comparable conventional long-nosed truck could legally or practically replicate. Number 9. 1988 Volvo F12. The Volvo F12 is probably the least known truck on this list among American audiences. But among European long-haul operators, it is spoken of with the same reverence that American drivers give to the Peterbilt 359 or Kenworth W900. Volvo introduced the F12 in 1977 and refined it through the 1980s, and the 1988 version represents the model's engineering maturity. The F12 was powered by Volvo's own TD120 diesel engine, a 12-liter inline six-cylinder producing up to 385 horsepower, developed entirely in-house by Volvo, including the turbocharger, fuel injection system, and cooling package. What made the TD120 remarkable was its thermal efficiency. Volvo engineers achieved fuel consumption figures in the F12 that weren't matched by many competitors until the mid-1990s. The F12 also pioneered a cab suspension system, Volvo called it the floating cab, that isolated the driver from road and drivetrain vibration in a way that was unprecedented for 1977 and remained competitive for over 2 decades. Drivers operating F12s on Europe's varied road infrastructure reported fatigue levels on long hauls that were measurably lower than in competitor trucks, a factor that directly contributed to safety outcomes. Volvo's attention to ergonomics in the F12, steering wheel angle, seat adjustment range, pedal positioning, established standards that influenced cab design globally. The F12 remained in production until 1993, and a significant number of examples continue operating in commercial service in Eastern Europe and Scandinavia today. Number 10. 1992 Mack CH613. The final truck on this list bridges the gap between old school and modern engineering. The Mack CH613, introduced in 1990 and perfected by The CH613 was Mack's conventional cab flagship, powered by the company's own E7 engine in displacements up to 12 liters and ratings up to 454 horsepower. The E7 was a mechanically injected pre-emissions diesel of extraordinary durability. Fleet operators consistently documented E7-powered CH613s reaching 1 million miles with only overhaul of injectors and minor ancillary components, not a full engine rebuild. 1 million miles on a single set of internal components is a benchmark that modern EPA 2010 compliant engines with their diesel particulate filters, selective catalytic reduction systems and exhaust gas recirculation coolers have not consistently demonstrated at scale. The CH613 also featured Mack's camelback suspension on the rear tandem axles, a trunnion-mounted walking beam system that provided superior traction on low-traction surfaces, particularly in construction, agricultural, and off-pavement applications. No modern production semi-truck offers this suspension configuration as a standard option. The CH613's cab was steel-reinforced, heavily sound-insulated, and built to a standard of crash protection that, while below modern Euro 6 and FMCSS standards, was exceptional for its era. Mack produced the CH613 until 2007, and it is still widely regarded by veteran drivers as the last purely mechanical heavy truck produced by a major American manufacturer, before electronic engine management and emission systems became mandatory across the industry. These 10 semi-trucks, the Kenworth W925, Peterbilt 359, Mack R-Series, White Freightliner WFT 864, International Harvester Transtar 4300, Kenworth W900A, Freightliner FLC 120, Peterbilt 362, Volvo F12, and Mack CH613 represent engineering achievements that solved specific problems with specific elegance. Modern semi-trucks are quieter, more fuel-efficient, safer by federal safety standards, and generate dramatically less harmful exhaust emissions than any truck on this list. Those are not small things, but each of these classic rigs possessed qualities: field serviceability, mechanical simplicity, driver feedback, structural longevity, or operational flexibility that current regulatory requirements, economic pressures, and design priorities have made difficult or impossible to replicate. The drivers who operated these machines weren't just nostalgic, they were describing real engineering compromises that the industry made, deliberately, in exchange for other benefits. Understanding those compromises is how the next generation of engineers might build trucks that don't force those trade-offs, trucks that are simultaneously clean, safe, efficient, and as durable and serviceable as the legends on this list. The road is always moving forward, but sometimes you learn the fastest by looking at what got left behind.